This is the review for the linear programming test on Friday. And this is Mrs. Vogt, so just remember sometimes Ms. Nelson and Ms. Delmont do things a little bit different, so feel free to ask them questions if you have a different answer or think that there's something different. So when I read these problems, I think to myself, what am I selling? What am I trying to make a profit off of? So I usually move to the end and read this one. The farm sells trees. So that is how I know that my X and Y are going to be my trees. So a fir tree and a spruce tree. So I'm going to write that here. Fir and spruce. Another way to think about it is you know how many pounds of fertilizer and how many gallons of water you can use. You don't know how many trees you can sell. So what you don't know is your variables. I don't care, Mrs. Vogt, if you put your X and Y along the side or along the top. I have a habit of putting mine along the top as long as you do it your way. That's fine, and be consistent. And then I like to write my variable here because that helps me write my equation. And then I'm going to put my other things that I'm talking about here, fertilizer and water, along this side. A fir tree is 4 pounds of fertilizer and 125 gallons of water. And a spruce tree is 6 pounds of fertilizer and 75 gallons of water. And then the reason I wrote my X and Y down is because I like to carry my X's and Y's down here. And then I know that we would use up to 750 pounds of fertilizer. So I'm going to say up to, which is less than or equal to. And the same here for water, less than or equal to 12,000. And that helps me because when I go and start to write my equations, for me, they're right there. They're kind of written right down for me. And again, it doesn't matter which way you put your table, as long as you are making your columns and rows kind of the same. So my first one I'm going to write is this one, 4x plus 6y less than or equal to 750. It doesn't look like a 7 or a 5. Uh-oh, I just erased something. It's not happy about that. Okay. So anyway, 750. And then my next one, I'm going to write an equation about water. 125 for every x plus 75y, and I can use up to, but not more than, 12,000 gallons. And then whenever you are doing a real life word problem, you have to remember those things like X and Y, like fir trees. I can't have negative fir trees and I can't have negative spruce trees. So a lot of times your last two equations are these kind of binding us to those real life constraints of there's no way to have a negative tree. Okay. So about graphing this. So I like to make t-tables and find x and y intercepts because I find that this also helps me when I am finding my vertices. If I already have the x and y intercepts, it's pretty easy. So I'm going to plug in 0 for x first. So that means I'm going to take 675 and divide by, I won't do that now, 675 divided by 750. And when I do that, I got 125. When I plug in 0 for y, 750 divided by 4, which is 187.5. When I graphed this also, I counted by tens, which meant that I ran out of room. So if you're looking at Mrs. Vogt's answer key, you will see that hers kind of goes up and off the graph. If you found that and you didn't like it, you could make a better choice by maybe counting by 20s or 25s. Just knowing that I counted by that, because then I had to graph 0, 125, which was like 12, 30, 40, 50, 60, 70, 80, 90. Here's 100, 110, 125. And my X was fir and my Y was spruce. I should label my system here. So I put a dot here at 0 and 125. And then here's my other one where I'm going to have to go way off the graph is 187.5, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, and maybe right here. And so now I'm going to draw my line. And hopefully, well, it was supposed to be a blue line, but it's okay. You guys understand. So there is my first line for, that was my equation about fertilizer. Okay, I'm going to do another t-table for my water line, x and y. If I plug in 0 for x here, I believe I get 160, and if I plug in 0 for y, I get 96. So 160, this was 120, 130, 140, 150, 160 way up here, and then 96 would maybe be right here. And so now I'm going to graph this line with these 2 points. Okay, and then my other 2 lines are binding me to this first quadrant where I have to stay positive. Okay, so those are my other 2 lines, my x equals 0 and y equals 0. And then shading, these mean I have to stay positive, so I would shade up this way and to the right this way. If I tested the point 0, 0 in my first equation, I would have 0 is less than 750, which is true, so I would shade underneath the green line. And for the purple line, 0, 0 would also be true, so I would shade underneath the purple line. So hopefully you notice that your feasible region is this little quadrilateral. It has 4 corners. Okay, and now I need to find the vertices, and the first one's super easy, 0, 0. And this is where I like having used my x and y intercepts, because if I look back at my x-intercepts here, I can see, here's one x-intercept, here's my other x-intercept. The point is going to be 96, 96, comma 0, because that's this point I graphed here. And then it's on the green line in this one. If I look at my y-intercepts, well, that's 0 and 125, and I can read that off my table right here, and I like doing that. The third one is the one that everybody seems to be having trouble with, at least in my class. And so in my class, we've talked a lot about what do you do? How do you find the intersection of 2 points? That is something that we've already done. Okay, we already took a test on that. And you either need to use substitution or elimination. So this is where these 2 lines meet. And when you're doing substitution and elimination, you need to just use the equal sign. So what I did, and you can see the work on mine, is that I multiplied my first line by 4 and my second line by 125, or sorry, backwards. Top line by negative 125. And the bottom line by 4 to have them cancel out. So I don't have a calculator up, so I'm just going to write down my new ones. You should be calculating these. So I get negative 500x minus 750y equals negative 93750. You do not have to choose the same multipliers as me. You might choose something completely different, as long as in the end we get out what we came for here and finding the answer. So when I do those, my x's go away. That's elimination. So I have negative 4,500x equals 450x. I'm sorry, equals, I'm running out of room. 45750. And when you divide both of those by 45, I've run out of room completely. I get y equals 101.67, or 101 2/3. So it was a big issue in my class. We were talking about when do you round, how do you round, why do you round down. First, you need to plug this number in to calculate the x value. So plug it in somewhere like 4x plus 6 and y 101.7 equals 750. And when you calculate this, you will get x equals 35. And that's what we want. That's the correct answer. And now you're going to round down when you put it in your vertices thing, because you can't sell 0.67 trees. So when I list all my vertices in here, I had 0, 0, 96, and 0, 0, and 125. In here, I'm going to have 35 and 101, okay, because you can't sell 0.67 trees. Don't round first and try to find the other one, round later and try to find it. Another thing I do is I usually try to go back a little and look at my picture. Is this look like it's maybe about at 35 and 101? I mean, yeah, it's pretty close. And so because of that, I think that I did a pretty good job. Write an equation for the profit. You're going to go back up to the top and figure out how much. I believe it was 30 for a fir tree and 40 for a spruce tree, and that's my profit. And now you need to plug each vertex into this equation and come up with the profit that you got. So when I did that, if you sell 0 trees, you don't make any money. For this one, I got, this one was 2880. This was 5,000. And the last one was 5,090. So vertex 4 is where I make the most money. So find the vertex point. So it's vertex 4. If the test would ask you to write a sentence about how to maximize profit, you would say, I need to sell 35 fir trees and 101 spruce trees to make a profit of $5,090. Okay, so that would be a complete sentence explaining what you know. Okay, so here's one without context. You still need to be able to do this. The first line that I'm going to make is x equals -2, so less than or equal to. It's not writing for me. So, oh, there we go. That's this one, x equals -2. And that was not supposed to be a dotted line. It's supposed to be a solid line. So that's my fault. I'll go over it with the line tool actually, and that should help be a nice straight line. So x equals 2 is this nice straight line, and it's all of x is greater than or equal to 2, so it should be a solid line, and you would shade this way because that's where the numbers are greater than 2. Now this one, whenever I see one in standard form, I always just make a table. So I have 5x minus 4y equals 10. If I plug in 0 for x, I get -10/4. You can type that in your calculator. You'll get -2.5. And it's okay. I can graph -2.5. That's not a super difficult decimal to graph, so I'm going to do it. When I plug in 0 for y, I get that x equals 2. So then that's here. You could also turn this into y equals mx plus b form and graph like that. Okay. So when I make a line here, this one is going to be dotted because of the less than sign. And so I just need to get through both of those points. And now I need to decide where to shade. So if I plug in 0 minus 0 would be less than 10. I would shade on the same side as 0, 0. So that would be this way. And the last one, the kind we already know we all like to graph, -1/2 x plus 8. So I'm going to count up 8. And then my slope is -1/2, so down 1/2, down 1/2, and so on. And then this will be a solid line. Back to my solid line. And go ahead and draw that one in. Now I need to determine where to shade. So if I plug in 0, 0, again, that's my favorite point to choose. Is 0 less than or equal to 8? It is. So I would shade this way. And I didn't do too bad kind of keeping it all contained. But my feasible region then is this triangle in here. Okay. And now I need to find my vertices. One here, one here, one here. And I do think it helps if you label your lines And when I label them, I do it with an equals. That makes most sense to me. So as I'm going through these, a lot of them I can count. I could also just plug in, like I called this vertex 1 on my answer key. It's where x equals 2, negative 2, meets 5x minus 4y equals 10. What you could do is substitution, plug it in. 5 times negative 2 minus 4y equals 10. 10 minus 4y equals 10. Add 10 to both sides. Negative 4y equals 20. And y equals, I ran out of room, negative 5. So vertex 1 for me is negative 2, negative 5. You can probably also count that out. It's a great idea to be checking all your work with algebra. I will do this one next because this is where x equals 2 meets negative 1/2 y equals negative 1/2 x plus 8. So I'm going to substitute 2 in for x. Negative 1/2, and I keep saying positive 2, but it is negative 2. And this equals 1. So y equals 9. So my next one, negative 2, 9. And that's up here, right? You can see it. It's on the picture. It makes sense. The one that's going to be the most difficult is where the two lines meet. 5x minus 4y equals 10. Negative 1/2 x plus 8. So since I already had an equation that was in y equals form, I chose to use substitution. So I'm going to substitute this in right here. 5x minus 4 plus 8 equals 10. Okay, so here's where I saw a lot of people in my class making mistakes, was this distributing part. You should have 5x. You're going to take negative 4 times negative 1/2 and get a positive 2x. And then again, negative 4 times positive 8, you're going to get a negative 32. So now I have 7x when I combine like terms. I have 7x equals 42. When I divide, I get x equals 6. Okay? And then I would plug that into any of my equations again. So I might choose the y equals equation. So y equals negative 1/2 6 plus 8. So y equals negative 3 plus 8, and that would be 5. So that is how I found my final vertex. Writing systems of equations. Again, I just start with equals and then I figure it out from there. So the first one to me was easy. I did this straight up and down line because I like that best. 1, 2, 3, 4, 5. So this is y equals 5. For this first dotted line here, I chose the x or the y-intercept is at 3, and then I counted up 1, 2, 3 over 1, 2, 3, 4, 5. So that line is y equals 3/5 x plus 3. Rise over run, remember that. And then for the last one, I see that it's 1, 2, 3, 4, 5, 6. Should be a minus 6. Computer can be very slow sometimes. I hope I didn't crash it. Not responding, that's not good. Something minus 6, and then I'm going to count 1, 2, 3, 4, 5, 6 over 3. So 6 over 3, that's 2, but it's a downward slope, so I need to have negative. Okay, so now I'm going to start thinking about how do I write this system of equations. So y and then 5 was my first one. I shaded here everything beneath it, so that would be all numbers less than, and it was a dotted line, so I have to keep it as less than. Okay, next one, y something 3/5 x plus 3. If I test 0, 0, I want it to be true because I've shaded there. So is 0 less than or greater than 3? It is less than. So I'm going to choose less than. I want that to be true. And then my last one, y negative 2x minus 6. If I test 0, 0, again, I want it to be true because 0, 0 is on the shaded side of this one. So is 0 greater than negative 6? It is greater than, but I also have a solid line on this one, so I need to make it greater than or equal to 6. Okay. Last bit. You're supposed to write 4 different points. So I know that was a bit of confusion here. So hopefully that clears it up. When you do this one, you're going to pick something that's in the gray area. When you do this one, you're going to pick that it's on a solid line. When you do this one, you pick that it is on a dotted line. And the last one, you should choose someplace in the white. When it says prove, that means show based on what you know, the equations, that it is or isn't true. So these have to have like 3 check marks because they are true. These have to have just 1 no. 1 no ruins the whole thing. Okay. So from gray, I'm going to pick 0, 0 for part A. So for A, I'm going to pick 0, 0, something in the gray. And now I'm going to try all 3 equations. So is 0 less than 5? Yep. Is 0 less than 3? Yep. And is 0 greater than or equal to -6? Yes. So for A, my point is good. B, pick something on the solid line. I'm going to pick this one here, which was 0, 6. Okay, this is B. So now it is a solution, so hopefully it works for all of them. Is 6 what did I do wrong? I did something wrong. 1, 2, 3, 4, -6 less than 5. There we go. Yep. Then I'm going to do the next one is -6 less than 0 times 3/5 x is 0. Is 0 less than 3? It is. Or I'm sorry, is -6 less than 3? And it is. And then the last one, I have to put -6. We're not responding again. Silly me for pushing a button. -6 greater than or equal to -6 when I plug in 0. And that is true as well. So we're good there. Okay, now on the next one, for orange here, I need to pick something on the dotted line, and I'm going to choose this one, which is 0, 3. It's supposed to be a comma, not a line. So remember, all I need to do is get 1 no, and then I've proven that it's not a solution, because a solution would work for all 3 inequalities. Just starting at the top, is 3 less than 5? We're good there. Is 3 less than 3/5 0, which is 0 plus 3. Is 3 less than 3? No. Okay, so here's our first no. We have proven it is not a solution. And then in anywhere here, so I'm going to pick, what did I pick? 1, 2, 3, 4, 5, 6. I picked 0, 6. And is 6 less than 5? It is not. So I've already proven it is not a solution of these systems. I hope this helps you study for your test tomorrow.